Today's topic of discussion is compressor work on PV diagram. You must have heard that the polytropic work is greater than isentropic work and isentropic work is greater than isothermal work. But have you ever heard that the reverse case? That means polytropic work is less than isentropic work and isentropic work is less than isothermal work in any case. This is completely new concept and you will not find this in any books or journal. Then you may think how I have come to know that that polytropic work is lesser than isentropic work and it is lesser than isothermal work. In fact, I was thinking one day for the compressor work for the open and closed system. While doing my calculation, I observed that in closed system, polytropic work is less than isentropic work and isentropic work is less than isothermal work. However, in open system, polytropic work is greater than isentropic work and isentropic work is greater than isothermal work. As this is a new concept for the closed system, so I have also validated with an example and proved that the polytropic work is less than isentropic work and isentropic work is less than isothermal work for the closed system. I have also seen another important finding is that isothermal work is the same for closed and open system. So let's discuss further on this. Compressor work head is defined as work per unit mass. So compressor work head is also called head or compressor head or head rise or only head. It is related to only compressor, not for any other turbomachinery. So compressor head is for open and closed system. So let's discuss compressor head in open system. Compressor head is defined as an integration of VDP for the open system. So A1, A2I, x-axis is a specific volume, Y is a pressure in Pascal. A1, A2I is isothermal process. A1, A2I, A1, A2S is the isentropic process and A1, A2P is a polytropic process. Isothermal head, HI, area under the isothermal curve on pressure axis. So area under this curve is called isothermal head. Similarly, for the area under the isentropic curve on the pressure axis called isentropic head. Similarly, for the polytropic head is the area under the polytropic curve. So with this figure, it is clear that isothermal head is less than isentropic head is less than polytropic head because area for isothermal is a minimum and area for the polytropic is a maximum. Compressor work in the closed process where work head is defined as a closed system. It is defined as a PdV. So isothermal process is A1, A2I. Isentropic will be A1, A2S and polytropic is A1, A2P. Same x-axis is the specific volume, y-axis is pressure in Pascal absolute. So isothermal head for a closed system, area under the isothermal curve on the specific volume axis. So A1, A2I, V2I, V1 is the area for the isothermal. Isentropic area for the isentropic curve for the volume axis. Similarly for the polytropic head, polytropic curve for the volume axis. So again with this figure, it is clear that isothermal head is greater than isentropic head is greater than polytropic head. So let us validate this. Let's say case of nitrogen. Gas is nitrogen. Inlet pressure is 1.5 bar absolute. Inlet temperature is 30 degrees Celsius. Outlet pressure is 3 bar absolute. Outlet temperature is 108 degrees Celsius. Average specific heat capacity ratio K is 1.4 constant. Average polytropic index N is 1.5 constant. Inlet compressibility factor Z1 0.999 constant is average specific heat capacity at constant pressure Cp is 1.045 kilojoule per kg per Kelvin. Mole weight is 28 kg per kilomole. Universal gas constant R is 8314.5 joule per kilomole per Kelvin. Inlet density is calculated P1 into 10 to the 5 into m upon Z1 into R into T1 plus 273.15, make it close. So density will be 1.668 kg per meter cube, and so a specific inlet specific volume V1 is 1 by RD1 is 0.6 meter cube per kg. Isothermal outlet specific volume V2I is V1 into P1 upon P2, so it is coming as 0.30 meter cube per kg. Isentropic outlet specific volume V2S is equal to V1 into P1 by P2 to the power 1 by K, so which is coming as 0.365 meter cube per kg. Polytropic specific volume B2P B1 into P1 by P2 upon P1 by P2 to the power 1 by N. So after putting this value, it coming as 0.378 meter cube per kg. So we have now seen V1, V2I, V2S, V2P. Isothermal head using the formula P1 V1 log P2 by P1, it is coming as 62,334 joule per kg, and isothermal head with using another formula Z1 into R by M into T1 plus 273.15 into log P2 by P1, it is coming same. There is another way through which we can calculate is coming at 62,334. Isentropic head HS is K upon K minus 1 bracket close into bracket start P2 V2S minus P1 V1 bracket close, putting all these values is coming as 68,935 joule per kg. Using another formula for isentropic head, it is coming as a same value 68,935 joule per kg. Similarly for polytropic head, n upon n minus 1 bracket close P2 V2P minus P1 V1, after putting it is coming as 70,124 joule per kg. Using another formula for polytropic head, same value is coming, that is 70,124 joule per kg. So with this value, it is clear that isentropic head is lesser than, isothermal head is lesser than isentropic head, and isentropic head is lesser than polytropic head. Enthalpy rise in the open process. Enthalpy rise is HA is equal to Cp T2 minus T1. So putting all this value, it is coming as 81,510 joule per kg. Now validation for the closed system. So isothermal head is P1 B1 log P2 P2 by P1. Putting all this value, it is coming 62,334. Using another formula for isothermal head, same value is coming, but this is same for the open process, so both are same. Isentropic head 1 by K, 1 upon K minus 1 into P2 V2S minus P1 V1. After putting all this value, it is coming as 49,239 joule per kg. Isothermal head using another formula, it is coming same value 49,239 joule per kg. Polytropic head using the formula 1 upon n minus 1 into P2 V2P minus P1 B1, it is coming 46,749. Using another formula for polytropic head, same value is coming, that is 46,749 joule per kg. So it's clear now, isothermal head for the closed process is greater than isentropic head, which is greater than polytropic head. Thermodynamic system PV diagram. So area under the A1, A1C, P1, P2, putting all this value, it is coming 90,000. Similarly, area under the curve V1, A1C, A2I and V2I, it is coming as a 90,000. So area under this curve, area under this curve are same. So summary of discussion is for the open process, work head is on the work head for the open process is on the curve on the pressure axis. Isothermal work head is minimum and polytropic work head is a maximum. So isothermal work head is lesser than isentropic head, which is lesser than polytropic head. For the closed system, work head is on the curve on the volume axis. Isothermal work head is a maximum, polytropic work head is a minimum. So isothermal work head is greater than isentropic head, which is greater than polytropic head. One more information, isothermal work head is equal in both open and closed system. So thank you for watching.